Hi, I'm Neil D'Souza. Welcome to the Troubleshooting Series for Azure Database for MySQL. This is the second part to the troubleshooting connectivity videos. In the first part, I covered some of the scenarios connecting to Azure Database for MySQL from a public network and a virtual machine within the same VNet, and also a virtual machine from a different VNet. Now, today, my colleague Ravi Shankar and I will be covering some of the private network scenarios involving multiple VNets in a hub and spoke model and physical network in an on-premise environment.
Hi, everyone. I'm excited to walk you through some best practices and a demo.
So let's get started. Okay, so let's see what are the topics we will be covering today. Firstly, private network, which we also covered in the previous episode, wherein we talk about networks, virtual network or private network configuration in on-premises, and hub and spoke model. So basically how multiple networks can be configured in a kind of a hub and spoke model, wherein one network acts as the hub, which connects multiple different networks together. And Azure DNS, we have DNS in Azure as well as on-premises, and there would be private DNS on. We'll learn more about what all these different aspects are. And virtual private network, which will help you connect from two different private networks, be it they are all on Azure or they are in a different cloud provider or on-premises. So here let's consider on-premise to Azure, how the connectivity is. Let's consider Azure Cloud with, let's say, Azure Database for MySQL database and Azure Virtual Machine. They are residing in a virtual network. And we have a DNS private zone on that virtual network, which maintains the name and to IP address translations for that network. And as we know, we have DNS at the Azure level, which helps us address the Azure resources. Let's consider the on-premises, wherein the client could be a server or could be a laptop or a device that's connected to the same network with its own DNS. And so we actually configure a VPN gateway on the Azure side onto the virtual network, and a VNet gateway on the on-premise side, which helps us connect the communication between the two. So for secure communication, we actually create networks in such a way that they are not exposed to the public. But the VPN gateways are kind of a secure tunnel that is built between the networks, which will be more secure communication between the private networks. So your data is secure. So let's take a deeper look at hub and spoke model. Let's consider three VNets, and two of them, VNet 1, VNet 2, let's consider them as spoke VNets, which have the Azure resources in them, and we need connectivity between them established, not through peering, but through a hub and spoke model. Now let's consider third VNet, which we consider as the hub VNet here, and we use custom DNS here so that we can establish connectivity from different VNets and do the routing. So here we will do the VNet peering from the spoke VNet to the hub VNet, but not between each other. And all the communication flows through the hub. And this acts as a central point for the connectivity, be it between the virtual networks in Azure or networks from on-premise. Now let's look at how on-premise network can plug in here. So here is a physical network with DNS configuration on-premise. Maybe it is configured with the Active Directory integrated, or could be a DNS setup, custom DNS setup on a Linux machine. Now we connect that to the hub VNet on Azure using VPN gateway, and it creates a IPsec tunnel to establish the communication, and which will be a secure communication. So it is not, though it is on the public network, but it is securely configured. And from here, I will hand over to my colleague Ravi Shankar for the further demo and some of the best practices.
Thank you, Neil. Here are some best practices which I'm going to cover. First one is the firewall rule. So, if the firewall rules are not configured correctly, both on on-prem and Azure, there might be blocking, and because of that blocking, the host cannot be reached or MySQL server would be unreachable. We might face some issues with the DNS resolution as well as connectivity. Second one comes as network security group. Network security group needs to be configured, and we need to configure proper inbound rules so that our connectivity to MySQL as well as to the DNS which we have provided both on on-prem and Azure should be there. Third one is the routing. Routing is important because if we tend to have a routing at subnet level, many a times we add a firewall at the end of the next hop. In the next hop, if the firewall is added, it tends to stop the connection both to your DNS server, which might tamper your name resolution, as well as it might affect your connectivity. Next one is the DNS configuration. DNS configuration is important as if proper name resolution does not work, many a times we do get the issue such as host not found, and then we tend to create host entries, which is not at all a very good practice. Because with flexible servers, there is a chance that during failovers, our IP might change. Next is adding virtual network link to the private DNS zone. Private DNS zone must have the virtual network link added for the virtual network, which should have access to the private DNS zone. If the virtual network is not added to the virtual network link of the private DNS zone, we might face name resolution issue. Forwarders are important part of custom DNS. Custom DNS, whether it is present on on-prem as well as on Azure. With custom DNS, if we do not configure conditional forwarders, there is a chance that the name resolution might not be taken to the private DNS zone, and hence the connections might not get established. Again, we would face the same issue that the host is unknown. Next, I'll walk you through the demos with hub and spoke model, custom DNS, and virtual private network. We'll start with hub and spoke network model. We see we have hub VNet and two spokes named test VNet 2 and testing VNet 1. I have created MySQL server in VNet 1 and the client machine in VNet 2. The DNS server is located on hub VNet. So it is the hub VNet where our VPN gateway resides, and it is the VPN gateway which decides the source and the target connection, even if they reside on different virtual networks. For VNet 2, we have specified the DNS server which we have created on the hub VNet. Now let's test the connectivity with the IP. In the place of hostname, I have used the IP address which is mentioned in private DNS zone for MySQL server. Let's test the connection. As we see, the connection is successful, but we will have to remember our IP address every time we need to connect. We have a simple solution. Adding the VNet, which hosts our custom DNS, to the virtual network link would give us accessibility to access the private DNS zone created for MySQL server, and hence the name resolution would work. Let's check if it works with the name resolution, as we have already added the hub virtual network in the virtual network link of the private DNS zone created for MySQL flexible server. Here we are using the host name, the FQDN of MySQL server instead of IP we used earlier. And right now we are going to test the connection. It prompts for the password. The connection is successful. Hence, it suggests that our name resolution is working perfectly fine. Let's check which DNS server is resolving our hostname. Using NSLOOKUP, we can get the IP address of the DNS server and if the host name is resolving to the correct IP. We see the exact IP and the name of our DNS server being used, and the IP address resolves to the correct IP of MySQL flexible server. It is also providing me the alias which is created in the private DNS zone. How did we make it possible? We use the custom DNS. The request from the VM would come to the custom DNS, which is hosted on the hub. And on the custom DNS, we have added conditional forwarders pointing to Azure public DNS. The IP address would remain the same 168.63.129.16. All the requests coming for MySQL database.azure.com would be forwarded to the public IP address of Azure. And since we have added the virtual network of hub to the virtual network link of the private DNS zone created, we do have access to the private DNS zone and hence the name resolution is working. So, for name resolution in hub and spoke model, we must have conditional forwarders pointing to the correct set of IPs. On the similar grounds, if we are trying to connect our on-prem virtual machine to our MySQL flexible server, we might need to configure a VPN or site-to-site tunneling between our on-prem environment and our Azure network. The tunnel is created from Azure Hub VNet to our on-prem VPN network. Using this tunnel, we can do the name resolution. However, we need a DNS server on Azure Hub VNet so that the name resolution can happen just like it worked in hub and spoke model. Let's check our network connectivity from our on-prem virtual machine to MySQL flexible server. Doing a ping test, we verified that our name resolution is working as well as the connection is also successful. For our on-prem connectivity, we just need to ensure that our DNS server is the same which is hosted on Hub Virtual Network so that the name resolution does not fail. The IPsec tunnel would do its job in order to connect your on-prem VM to your Azure database for MySQL flexible server. So this was the perfect use how we should configure our hub and spoke model, how we should configure our custom DNS along with conditional forwarders, and how virtual private network works in order to connect from on-prem VM to our Azure MySQL flexible servers.
Thank you, Ravi, for covering the demo and the best practices. And thanks everyone for watching here. And for further reading, you can go to our one-stop shop for resources related to Azure Database for MySQL on ak.ms MySQL-resources. If you have feedback or questions, please reach us on the email address askAzureDB for MySQL. And for more updates, announcements, or roadmap related to what's coming next to our product, follow us on social media. And thank you everyone for listening in. Please watch out for more episodes on the troubleshooting series for Azure Database for MySQL.
Thank you.